Let's go to new things. All right, so here we go. So we're doing kind of the same stuff today at the beginning. We have our 2 hours together. We're going to cover 2 sections. Last time we spent the whole time with 1 section. We're going to cover 2 sections, but the first one is almost identical. It just has one small difference. And that is what? What's the difference between this problem and all the ones we did yesterday? What's in the middle? Subtraction. All the ones Monday were adding in the middle. This one is subtraction. So, in fact, let me just write the rule. When subtraction in the middle, move the subtraction symbol to upper right and distribute. Then add. Then add is in middle. Well, let me say it this way. Then nothing is in the middle. So add. So add. All right. So what am I saying? I'm saying when you've got a minus sign in the middle right here, the first thing to do is to take that minus and go boom, boom, and distribute it to the upper right. And that way you won't have to deal with it anymore. Because otherwise it'll be hanging around here and there and can really mess you up. Yeah, James.
So then when you get a denominator that's flipped wrong, and you flip it back to give it the
minus that kicks out,
change it again.
you let it come back up and change it again. Exactly. You're thinking right. Exactly. Because it'll float out and go up and boom, boom, hit again.
Okay.
Exactly right. Exactly right. You're getting it. Yeah, exactly. We're distributing to all of them. Yeah. Yeah, let me make sure this makes sense first off for you as well.
If that's positive too, but it's negative now, we've turned it to a positive. Correct?
Right. It'll change what it, so if it originally had minus, it'll change it to plus. Yep, you're getting it. Exactly. Yeah, so that minus is going to distribute to the upper. Why am I only going to the top? Well, remember, let me give you a couple. I don't want to just say, hey, do this. Let me give you a couple reasons. Remember when we have a negative on a fraction? We've talked about this before, like slope and things, remember? It can go on the top only or on the bottom. They're all the same, aren't they? Remember that? So, yeah, could you put it on the bottom? Yeah, you could. It's not, though. It's not okay to put it on both because that's actually positive, huh? So everybody remember that kind of thing? One negative on a fraction, which is really what we have here, right? One negative in the middle. Really can go to the top only or the bottom only, but not both because 2 negatives would really be positive. That wouldn't be right. So I choose to put it only on the top because I don't want to mess with the bottom. I'm trying to get common denominator down there. So I take it only to the top. But that's right. That's true for a fraction, huh? So that's the first thing to remember. So I just let it go everywhere on the top, and it has to hit all the terms. So what does that mean? So the first thing I'm going to get, the first fraction, I'm not going to change it at all. But the second fraction, I'm going to let the minus go minus 9x minus 2. Everybody tracking with me on that? Oh, yeah, we do, huh? Everybody see what happens. So that minus sign that was in the middle hit both the 9x and the plus 2. And like James was pointing out, if that plus 2 was originally a minus 2, then when the minus hit it, it would go back to plus 2. It just changes whatever it originally was. And it'll change all the things on the upper right. Whatever they originally were, all the upper right signs will change. All the upper right signs will change when the minus goes to the upper right. Now, the minus has left. There's nothing in the middle because he left. He went to the upper right. So what does that always mean when there's nothing in front of something? What sign is really there? Plus. Yeah. That's why I'm saying this stuff about then nothing is in the middle, so add. That's always the case, right? When there's nothing. Do you know what we just did effectively? If I can, again, give you one more logical thing. If you have 5 minus 3, say, is that any different than 5 plus negative 3? It's the same thing. It's 2 either way, huh? That's effectively what we just did. Instead of subtraction in the middle, we added the opposite. We added the negative. Instead of subtracting 3, we added negative 3. But that's the same answer, isn't it? I'm not really changing anything. I'm just making it easier for us to do the problem. So my main point in all this is never subtract. Instead, add the opposite. Right? Never subtract, instead add the opposite. It'll be easier. It'll just be easier. So whenever they have, so never subtract fractions. Never subtract. So let me just write that. Never subtract. Never subtract. Instead, add the opposite. It's the same result, and it's easier. All right. So with all that said and done, you know what to do at this point, right? So what do we do now? They already have the same denominator, don't they? So I don't need to really mess around in any way. I can just go 10x minus 9x is x. 5 minus 2 is 3. Now the bottom I should factor. How does the bottom factor? What multiplies to be 12 and adds to be minus 1 in the middle? What times what's 12?
4 and 3.
3 and 4. How do you get negative 1 in the middle? Sign in the middle?
Bigger number.
Goes on the bigger. So minus in the middle, minus on the 4, plus on the 3. Is that good so far? That makes minus 1 in the middle, right? Sign in the middle goes on the bigger. 4 is bigger than 3. Now, can I do any more? Everybody see what happened so far? Right, I just combined the tops, didn't I? 10x minus 9x made 1x. And 5 minus 2 made 3. Okay, now in the bottom, those were already common, weren't they? So I didn't need to give them what they're missing or any of that kind of stuff because they were already the same. It's only when they're different that we do the give them what they're missing thing, right? To make them the same. James?
You couldn't just leave it at x squared minus x minus 1 at the bottom, no?
The reason you couldn't is because now this is going to happen.
Okay.
So yeah, because it reduces, you have to do that. What does that leave on the top? There's nothing on the top. 1. It's 1 over x minus 4. We're done. Does that make sense? Right, whenever the top of a fraction totally cancels, that always leaves 1. Even like just 2/6 or something, that leaves 1/3, huh?
So we only have to factor 1 in the bottom?
Only have to factor, what's that?
Only factor 1 in the bottom, the denominator?
Well, they actually would both factor the same, so you could do both, but it would just be the same thing twice. So yeah, it's just the same thing twice.
So wouldn't the x minus 4 cancel out too then if you wrote it twice?
Oh, but it never goes twice, right? Because these two denominators are the same. Right? Remember? Always keep in your mind the big idea. Just think about like if I have 1/7 and 3/7. I combine that to be 4. I don't write 2 7s, huh? I just keep 1/7 even though there were 2 here.
Oh, okay.
Right? Remember when you're adding or subtracting fractions, common number, you just carry one of them over, huh?
Correct.
So that's what I'm doing here. They're the same, but I just carry one set over. Yeah, good. Yeah. Yeah, where'd that 1 come from? Yeah, good question. Think about like what if we have something like 2 over 6? What would be the reduction of that fraction? What does that reduce to be? 1, 3. Now where'd that 1 come from? 2 goes into 6 3 times. Where'd the 1 come from? We always put a 1 in the top of a fraction when it cancels, huh? Always. I'm not doing something new there, am I? See how that 2 cancel with nothing left? We always leave a 1. Yeah, the reason for that is because you're really dividing. I don't want to write it all out every time, but really I'm dividing by x plus 3, dividing by x plus 3, top and bottom. That's really what's happening. Anyway, enough said. All right, good. Okay, what's the first thing you're going to do on this? There's subtraction in the middle. This whole section is subtraction in the middle. What do? You never subtract, right? Instead, take that minus sign in the middle and distribute to the upper right. Change all the signs in the upper right. And then make it added. So you add the opposite. Never subtract. Add the opposite of the upper right. Take that minus. Boom, boom. Oops. Try that again. Everybody see that? And then we change to adding. Is that good, that first step? So we always let that minus sign in the middle distribute to the upper right, changing the 8v to negative and the 23 to positive, huh? It changes all the signs in the upper right, and then we make it adding. So we're adding the opposite instead of subtracting because it's easy. All right, now you got to make those bottoms the same. They're not the same this time, right? Give them what they're missing. Play the compare to your neighbors. What do they have that you don't have? Which is bad to do in real life, but great for math. So come to this one. What is this first one missing that his neighbors have? An 11. Give him 11 top and bottom. Is that good? Right? Whatever. You give him what he's missing. But you got to do it top and bottom so you don't change the fraction.
Just 11, not 11b.
Right, because he's already got the v. Right? When you look over it, he says, oh, I got a v. Right? I just need the 11. So you just give him what he's missing. He's only missing the 11. And what about the second neighbor? What is this neighbor missing that the other guy has? Nothing. He's got it all. He's a neighbor that's got it all. All right. All right, so here we go. This now, can you take it from there now? Are the two denominators the same now? They're exactly the same, aren't they? The two denominators are exactly the same. They're both 11b. So you don't need two of them. You just need one of them. All right, and then distribute. 11v minus 66. Good. And then you can write plus minus 8v, or you can just write minus 8v. It's the same thing. Plus a minus is just minus. Good so far? And just combine them. 11v minus 8v, what's that, 3v? Minus 66 plus 23, was that minus 43? Over 11, that's a v there. That's it, huh? That good? So never subtract. Instead, add the opposite of the upper right and give them what they're missing. Questions on that one?
This is remembering steps.
Yeah, it really is. Yeah. So it's good as you do your homework, when I write out steps, keep the steps in front of you, and then try going through the steps with the homework. Yeah. Yeah, right. So then when this sign goes up, it change, and make this plus. Always. Change all the signs. Exactly. So change all the signs. Because the minus does that. You know how a minus sign changes? Right? You know what I mean? Like if you have a minus in front of an 8v minus 23, it's really a minus 1. That's what this really is here. It's really a minus, let me see if this helps. That's really what's happening. It's like a minus 1 that's distributed, make it minus 8v and plus 23, huh? That's what's really happening. That minus in the middle is a minus 1 multiplying the upper right. That's why it changes. It's distributing through the upper right.
As soon as you bring it up there.
As soon as I bring it up there. Yeah. Yeah. That's right. Okay. So let's try that one. So 17pc over p squared minus c squared minus p minus c over p plus c. All right, so what's the first step? Well, first we do the subtraction thing, but then we'll go back to the stuff. But so first never subtract. Always do that first. Never subtract. Take that minus sign in the middle, and it's a minus 1 distributing to the upper right. Right? Never subtract. Minus 1 multiplies both those, changing both signs, and then it becomes adding in the middle because there's nothing in the middle, it's left. Good. So it becomes plus minus P plus C. Is that good to there? And then we factor. Right, that P squared minus C squared. P plus C, P minus C. Right, that's an FL, front times front, last times last.
Oh, you factored it.
Good? Right, how we always factor at FL, right? Front times front, last times last. P times P is P squared, C plus C minus C is minus C squared. All right.
Now we gotta get the neighbor.
Yeah, now look at your neighbors. What do they have? You guys are going to do this when you go home, huh? You're going to look at your neighbors. They do have a nicer car than me. That grass is greener. My neighbor's grass across the street and next door have always been greener. Much greener. Throughout the years of living in that house. And I've always asked Charlie across the street, really nice guy, how do you do it, Charlie? And he's told me different things, and I've tried all these different fertilizers and different things, and my grass always looks yellow. And then one day, paint it, paint it. And then the weed man, you guys know the weed man comes around, advertises, I finally said, I'm just cheap. I got 5 kids, I don't have money for that. I finally said, all right, I'll put out a little money, try this weed man thing, because my lawn always looks terrible.
Just buy fake grass.
And it was 1 month, and that lawn, I could do a commercial for them. My lawn looked beautiful. They've got it going on. I don't know what those chemicals are, but they know what they're doing. It is totally worth it. And I'm cheap, but it is totally worth it. And then I went across the street, and my lawn's looking as good as Charlie's. I was talking to Charlie, and I saw the weed man pull up at his house. I thought, you've been doing the weed man all these years? And you didn't tell me? And I kept asking you why your grass is greener? He was keeping a secret from me. All right, there's my small little life. It's all about my lawn and my car. All right, so we're comparing to the neighbors. What this neighbor looks over at that neighbor and says, what does he have that I don't have? Nothing. Right? Now this guy's turn. Now he looks over at him and says, what does he have that I don't have? P minus C. P minus C. Okay, but this is going to FOIL up here. So I go ahead and put parentheses around the minus P plus C that was already there. It's going to FOIL with the new P minus C. By the way, they're the same now. See how the two denominators are the same now? When I gave the second one what he was missing, the other one had. Right? It's going to FOIL now. So let's bring it up here. Kind of running out of room. So 17. It's going to make it 1 for... I don't need 2 of them anymore. They're the same on the bottom. So you don't need 2 of them. Bring the 17PC up there. Right? 17PC. And then FOIL this other side out. So I'm going to go, okay. That's, boom, boom. That's going to be minus P squared plus PC. Boom, boom. Plus PC minus C. Am I in the screen? Yeah, good. Minus C squared.
So it'd be 2PC.
Yeah, right. It'd be 2 PC. And then 17 more, so 19 PC, yeah. Yeah. Did everybody see what happened there? Everybody see how that's working? Right? So I had to give this right fraction what he was missing, P minus C top bottom, and that made a FOIL happen. Careful with the signs. And I brought it all up here, the 17 PC, and then all the blue FOIL stuff. Is that good? To there. And now I'm gonna try to gather like terms. So here we go. Minus P squared. Doesn't really matter what order you do them in. 17 PC, 1 more and 1 more is 19 PC. Minus C squared over P plus C, P minus C, done. Doesn't matter what order you have those on the top. It's fine, any order. Or the bottom. Yeah. So we're done there. Is that good? Questions on that? You okay with how I gathered like terms up here? 17 PC, one more and one more, 17, 18, 19 PC, right? And then the minus P squared, the minus C squared. Questions on that? We good? Can I move on? We good? Got it all down? Okay, so we have 3 minus x over x minus 6 minus 5x minus 4 over 6 minus x. Okay. So, now, look at this right here, guys. Remember what we're supposed to do with those things that have x subtracted in the back? What are we supposed to do with it when there's x subtracted in the back? We're supposed to flip it around and a minus floats out, right? Remember all that? So I'm going to turn this around, make it x minus 6, but a minus comes in front. It's called the turn around. When x subtracted at the back, turn it around, negative in front. Right? So that's what happened there. So whenever, and that's denominator. I don't care about numerator. I'm not, you look up here, yeah, I'm not going to go up here with this 3 minus x in the numerator and do anything. I don't care about the top. All my focus is on the denominator, right? Common denominator. I'll worry about the numerator at the end of the problem. The beginning is all about the denominator, right? So I flip that around, turn around that 6 minus x to be x minus 6, and put a minus in the front. And now, where does that minus go? He floats up here. So what do we got? 3 minus x over x minus 6. We've got the minus that was already there, and the new minus. If I can keep the colors the same here. There. Does everybody see what happens? This new minus is now there. So we got 2 minuses, which is what? Positive. And they're gone. Poof. 3 minus x over x minus 6 plus. Everybody see what happened there? James?
That second minus doesn't distribute over to the negative 4?
You could take them both up there.
Yeah.
So a couple of options. Here's a couple of options.
Yeah, it's 5 and 4.
So the subtraction that was already there, and the new minus that popped out because of the turnaround, 2 minuses make a plus, or from the beginning I could have taken that purple minus and went to the upper right and change, right? Make it negative 5x and plus 4. And then the new red one
Makes it
would have his turn, it would change it back.
positive 5, positive 4.
Positive 5 back to negative 4. Right? That makes sense? So instead of doing all that, it'd be quicker just to say, look, 2 negatives are going to undo each other. Right? One of them is going to change all the signs, the other one's going to change it back. So might as well just skip the whole thing and leave it the way it started. Does that make sense? That's what the 2 minuses do. So when there's 2 minuses, one of them will change all the signs and the other one will change them all back. So 2 minuses, just make them plus. Don't let anybody change anything. It's the same result. Does that make sense there? And then what does that equal? Common denominator. We already got common denominator. There's none of this neighbors and stuff. Yeah, negative 1x and 5x. Negative 1 and 5 is 4x. 3 minus 4, negative 1. There we go. Question?
How could you not distribute it to the top anyway?
Yeah, I would have, except the 2 minuses cancel each other out. So if I'd only had 1 minus in the middle, I definitely would have distributed it. But if you have 2 minuses, then they cancel out. There's no more minus in the middle to distribute anyway. Does that make sense? And why are there 2 minuses? because I did that turnaround thing on the bottom.
Cancel.
Right, you turn that around. There was already a subtraction from the beginning.
And you're gonna lose.
And before he was waiting to distribute, you know, when I did the turnaround, another minus popped out of the bottom, came up here and canceled out that minus. Does that make sense? So when you do a turnaround, a minus pops out and floats up. And if there's already another minus up there, the two minuses cancel. There's nobody left to distribute. We happy about that?
You can see the first negative, you're gonna move it up next to the 5, right?
Okay, I could redo it. I could do it the other way. So I could instead say, look, I'm just gonna, what I did is I just held off on moving the first negative.
Okay.
And I did the turnaround first. But you could say, I'm not gonna hold off, I'm just gonna move them right now. Okay, yeah, you could do that.
I got it.
And then there'll just be plus there. And he'll go negative 5x plus 4. Okay, like that. And then you're gonna go, okay, I'm gonna turn this around to be x minus 6 and a minus in the front. Does that make sense? And then that minus would come up here.
Now you got 2 minuses.
Well, and then he's gonna distribute and change them back. So that's just more work. So I just held off on letting the first one distribute, is what I did. It's just easier that way, just to hold off. Let's try now. It'll make more sense as we see more and more of these. Okay, so I'm gonna make it an x here. So 4, whoops. Parentheses, 5x plus 1. Over x minus 3 minus 4. Parentheses, 5x minus 4. Over 3 minus x. Plus 2x minus 3. Over x minus 3. There we go. All right, let me, who needs to be turned around there? In the middle, right? In the very middle. This one needs to be turned around, become x minus 3, and a minus in the front. So any denominator with x subtracted in the back needs to be turned around. Minus comes out, and where does that minus go? He comes up here, doesn't he? And it's going to hit the other minus that's already in the front, and the 2 minuses will make plus, right? So that makes sense what happened? These 2 minuses made plus. Is that good? Now just distribute the tops and combine. Because everything's plus.
28. Plus 2x minus 3. Or we have 26 at the bottom. So that's 42x. 4 minus 16. 4 minus 16? Minus 3.
So this and this is negative 19 plus 4 is 15.
Minus 16.
This is negative 19 plus 4. Do it again. What'd you get with the other 4? 3, 16, and 12. Plus 4, so just 4. Minus 16, minus 3. Plus 4, minus 16, minus 3.
Minus 15.
Right.
Wait, is it 19?
When you added them, these 2 is minus 19. Plus 4, minus 15.
Oh, but I think I had the bottom.
Okay. So now we can combine these.
So smart.
multiply 20x plus 4. 4 distributes. 20x minus 16 plus 2x minus 3. And I think that we can just combine now, right? What do we got? We got 20x and 20x is what? 40 plus 2, 42x?
Yeah.
4 minus 16, what's that? Minus 12, minus 15? There we go. That good? Does everybody see why the minus sign did not distribute these last two problems, but it did on the other problems? Does everybody see? It's all about if the minus gets canceled out, turned into a plus, then it can't distribute anything. Right? Do we all see that? Right? So on this problem, that minus sign in the middle, he never got to distribute to the upper right at the same time because he got canceled out by the turnaround minus that popped out of the bottom. It's like a new minus popped out and said, no, you're not going anywhere. Boom, you're changed to positive. So before he had a chance to distribute, another minus popped out of the turnaround on the bottom, changed into plus. So the only time those minuses will distribute to the upper right is when the minus is not changed to plus by another minus. It turns around on the bottom and changes it. Right? We all see it now? Making sense? Okay. Questions on that one? Yeah, we better. Let's do this. You know how they keep factoring? I don't like what they're doing with the top on these problems. Let's just distribute those tops right away. Let's do that. I don't like all these parentheses. We don't want parentheses in the top. We want them in the bottom for common denominator, but we don't want them on the top. I think they're just messing with us. Let's just distribute that. 7w minus 56. I'm just going to multiply the tops. I'm not going to do anything else right now. Distribute that top. 8w plus 56. Bless you. So all I did was multiply those two tops out. Is everybody okay with that? I don't want those parentheses on the top. Is everybody seeing what I'm doing there? Let me just write a note. No parentheses left on the top. You don't want to leave parentheses on the top. No parentheses on the top. The bottom is fine, not the top. So now, go ahead and do it like normal now. So now just go ahead and do the normal steps. Does anybody need to be turned around?
7W.
So I'll do all that stuff now. Yeah,
Does that save us that?
I think it's easier just to get rid of those parentheses on the top right away. Yeah. They're not going to often do that. You're right, I did it later. Yeah, you're right, I did. I think you should do it first. Yeah. Technically, you could do it at any time, but it could miss. If you did it, yeah. I think this is easier. You technically could do it at either time, but this is easier. See, right? I know. Okay, did you? Okay, which one are we looking at? What about the denominator in the middle?
It's on the end, I did it.
Okay, a couple things. How did you get, we got 8 minus 8w plus 56? Did it hit everybody or just the front? Okay, so there's one thing. Now over here, when you do the turnaround on the bottom of this one, the minus doesn't come out and hit that minus, and they'll be gone. Here the minus will hit that minus when you turn around. So there'll be no minus on the last one.
That should have been the first one.
All right, so what are we going to do now?
Flip the.
This guy needs to be turned around, and a minus pops in the front, goes up there, 2 minuses, plus. With me? That's going to become a plus. Right? We've had that a couple times now, right? So whenever the letter is subtracted at the back. Right? When the letter is subtracted at the back, turn it around, minus pops out, goes up, hits the other minus in the front. Right? So then it becomes plus. We good to there? On there with the turnaround? What happens in the middle? This minus is going to go there and there. Because nobody cancels him out. This making sense? We all seeing that? Guys, let's have math talking, please. All right, we good? Everybody see that? Everybody tracking with me? So the minus at the back end was canceled out by the turnaround, right? We've seen that a couple times now, right? So that the minus at the back never went up to the upper right and changed signs. Why not? Because the turnaround, because the letter was subtracted at the back underneath him, the turnaround pulled out a minus and canceled him out. But the one in the middle, nobody's canceled him out, so he is going to distribute to the upper right and change all the signs. Everybody see that? This is a perfect example of both cases. One of them at the back where the minus is canceled out and never has a chance to distribute to the upper right, and the one in the middle where it's not canceled out and has a chance to distribute to the upper right. So you see that difference? We've had that in a couple different problems, but here it's both in one. It's kind of nice. I think it's clarifying. Does that make sense then? You see when it's canceled and when it's not? Right? So again, the one on the end, this one here, is that minus is canceled out by the other minus that pops out of the turnaround and changes it to plus. So it never stays minus. But the one in the middle, he stays. No, this doesn't need to be turned around because the W's in the front. Right? The denominator of the middle does not need to be turned around. So therefore, no extra minus pops out, changing this minus in any way at all. So he stays minus, and he goes, I'm still minus, so I need to distribute to the upper right of the middle fraction. Good? All right, so then what do we got? We've got 7w minus, I'm just bringing the first one down, no changes. The middle one now will become plus because the minus is left. Minus 8w minus 56. Is that good? Remember, after the minus leaves, it's plus. All right, now, the three denominators match. Don't need three of them. Just make one of them. What do we got? 7w minus 8 is minus 1 plus 1. There's no w? They cancel out. And then the numbers are minus 112. Minus 120?
Yeah.
Know what it is? Use your calculator.
Yeah, so far.
6 and 56 is 112. You don't take the 8.
They're all minus. $56 loss, $56 loss, $8 loss. Big old loss. Question?
I just got confused because of that rule, and I thought that the same rule applied over here, so I'm like, why is
What
it
rule's
plus
that?
if the negative, wouldn't it be a negative because I,
This negative here? You asking why is this not negative?
yeah, I thought that was gonna be.
Yeah, because he left. See the arrow? He's not there anymore. He traveled. So he's gone. So when there's nothing there anymore, nothing in front anymore. So what is nothing in front of something mean? Plus. Does that make sense? So whenever the minus leaves, distributes to the upper right, it leaves nothing behind, which is plus. That good? Other questions? So that's always what happens, right? These minuses distribute to the upper right. All right, let's move along. So there we go. All right. W minus 1 over W minus 5 minus W plus 1 over W plus 5 plus W minus 45 over W squared minus 25. Okay. So try that one. Anybody need to be turned around? No. There's no letters subtracted at the back in any denominator. Got to factor that third denominator, huh? And we have one subtraction that's going to need to distribute to the upper right. Right? Everybody seeing it? This guy's like, oh, I need to go here and here. And this needs to be factored. Right? Dash, try that.
Did you do it?
Yeah, I'm thinking sure like they'll make another one to make it. The 0 and the 2 or 3.
It's 2. But then you have to keep whatever they don't have and then do it to the top. You have to distribute.
So we good to there so far? How we doing? Is that good so far? Now we got to play look at the neighbors. Give them what they're missing. Are we good so far? Does everybody see what's happened so far? All right. So this guy's looking at his neighbor. What do some of his neighbors have that he doesn't have? That first question. W plus 5. Right? Give it to him top and bottom. How about the middle fraction? What's he missing? The minus 5.
And will those two cancel each other out?
These two?
No, double.
Well, let me clean that up again.
I'll wait.
And what does the third one need that his neighbors have that he doesn't have? Nothing, right? He's a neighbor that's got it all. All right. So we good so far? So now, one big bar. What's the common denominator? W plus 5, W minus 5. We don't need two of them anymore. What do you do on the top? You got a FOIL. Minus W plus 5W minus 5. And now the middle one. FOIL. Got to be careful with your signs, really careful. Minus W squared. I can't tell, is it a minus? Yeah, so plus 5W minus W plus 5. And then the last one just drops down. What a mess. You see all that? So long. These are not for the casual. Cancel. That's all. Then there's a bunch of numbers, letters. Yeah, you could do that, huh? I'm just going to combine everything at this point, and I'm kind of like out of room. What do we got? We got, well, what do we got? Bunch of W's, huh? So minus 1W plus 5 is what, 4? 5 more is 9, minus 1 is 8, plus 1 is 9. 9W? Is that what you guys got? No? Nobody got that?
I got 9W.
Yeah, I think that's right. And then, and the minus 5 plus 5 can cancel. 45. Well, it's minus 45, isn't it? What a mess. Over W plus 5, W minus 5. Oh, this is a terrible problem. Because it's not done, do you realize? It's not even done now. That top will factor. Do you like this? This is to separate the A's from the B's. These are the A people that'll get these right. Is everybody good there? Everybody got that copy down? I'm going to go to a fresh screen here. Minus 9W minus 45. Because I'm actually not done, if you can believe it. Still not done.
Negative 9.
Is everybody good there? Everybody got that copy down? Now, how do you finish this? Take out a 9. Cancel. There we go. That was something.
Oh, can I see it?
Let me go back to the screen.
Back there.
It's just a big mess of like terms. You just got to be super careful. See all that questions? I got to move on, guys. Grab me after. What? Second screen? So that's just to factor out the negative 9. I can't. I'm sorry. Grab me after. There's. Sorry, I just have a lot more material in the next section I got to cover, or I won't be doing you any favors. All right. So the next section is brand new. Most of that last section was review, although it wasn't easy at all. But it still was mostly the same. This will be similar too, though, actually. Anyway, the difference in this section from the last two sections is their equations, meaning they have an equal sign. If you look back to all the problems, we'll look back. Here we go. Look at that. No equal sign anywhere, right? No equal sign.
Nope.
So now we have an equal sign. We have, which means what? We have a left and a right, a wall. We have an equal sign. These will be easier. So you've made it. If you made it through those last two sections, you made it through the hardest stuff. This will be easier. First thing is we need a common denominator. Remember how to find the remember the box thing?
The L.
Do the box thing, the L, put the 11, the 3, and the 9, all the denominators in the box. Remember that? What goes into couple those? What number goes into 11 or 3 or 9? 3 does, huh? 3 goes into 3 one time, goes into 9 3 times. You with me so far?
Yeah.
And then just bring down the 11. Does that make sense so far? And then what goes into 11, 1, or 3? Nothing. Nothing but 1. 1 goes into everything. So then where's our common denominator? Multiply these together. What do you get? 99. Good? So I just multiplied those together. I get 99. And here I'm going to write a note. Because we have an equal sign. Because we have equal sign, multiply 99, the top of every term, left and right sides. That's the new step, and it'll be nice. Because we have an equal sign, multiply the 99 in the top of every term left and right. So what I mean is, I'm going to go 99, 99, 99. So everybody hearing me on this? This will make life so much easier for you in this section. What people tend to do is go, no, mister, I got to make the bottoms all be 99. No. I'm changing the game plan. This will be way easier. And we're allowed to do this now, and we weren't allowed to do this before. I'll get into more of those details later. Let's just get the hang of it first. Does everybody see that? I'm not doing the top and the bottom. Notice. I'm just doing the top. Everybody see that? Everybody see what I'm saying? I'm putting 99 in the top, top, top. Just the top, not the bottom. Everybody seeing that? Notice I'm not doing this. Let me show you what I think it's worth it to show you what I'm not doing. I'm not going, oh yeah, I need to multiply top and bottom by 9, so I'll make that bottom 99. No, I'm done with that. No, don't do that. That's the mistake a lot of people make who are in the old mode that have trouble shifting to the new mode. Are you seeing what I'm saying? I'm not making the bottoms the same. I'm going to wipe them out instead. This is way better. This will be way easier. We're allowed to do this with an equal sign. We couldn't do it before. Anyway, I'll hold off those details for some other time. But everybody's seeing, you're not doing the bottom. I don't know how more clear I can say it. I say it and I say it and I say it, and then I'll work with people and now they're doing top and bottom. I'm like, whew, what happened there? I said it and I said it and I said it. We changed gears, right? Top only. Top only. All right, so what do we do now with that top? So we cancel 11 into 99. Use calculator if you need to. 9 times. 3 into 99. 33 times. See what I'm doing? I'm canceling. I'm using that 99 like a tool to hammer out those denominators, right? You see that? I'm just hammering them. They're vanishing. Right? So what's left? 9 times 9, 81. Minus 33 times 1, 33, equals. What about the right side? 9 into 99. 11 times x, 11x. Does everybody see what happened there? So I cross-canceled and multiplied the leftovers. Everybody hearing those phrases? Cross-cancel, right? And I'll write it out in a second. So I put the 99, top, and then I cancel the denominator into the 99. 99 divided by 11 is 9. The leftover 9 multiplies the other 9 that was already up there. See, these guys are canceled. Please, show the canceling. Don't skip that. I don't know why students do that. I work with students all the time, and I'll see them. I mean, they're just killing themselves. I just don't understand it. They'll put the 99 here, the, what was the original thing? 11 here, and they'll just kind of like look at the whole thing, and they'll write the 9 here, and they'll go, I don't have any idea what comes down. No. Gonzo. Show that. You want to be clear what's gone and what's not gone. And the way it'll show that is the canceling. Cancel what is gone. Cancel what is divided. Not 11 and 99 are bye-bye. They're not there anymore. Right? They are canceled, off the scene, removed, gone. What's left over then? 9 and 9. Make sense? So when you divide, cancel. Don't not write that down. Do write that down. Show that canceling. Because that's what confuses people. They have nothing canceled, and then they kind of look at the big mess of numbers everywhere, and they're like, I don't know what's there. Well, I don't know either, because you're not showing what's gone. So make sure you show what's gone. Right here, too. 3, 99, gone. What's left over? 33, 1. Made 33. Right here. 9, gone. What's left over? 11x. Make sense? So show what's divided, they are gone, and what's left over. Right, so what does that mean then? Now it's a lot easier. Look at that. No fractions. That's why this section will be so much easier. On your first step, the fractions will vanish. No more fractions. This is cake. 81 minus 33? I don't know. What is that? 40? 48. Thank you. 48. 11x. How do we solve for x? Divide by the 11. You could do that problem before you came to class on the first day. These will be easier. So notice we're doing something different. We're not looking at the neighbors, making us buy what the neighbors have. We're changing within equal sign problems. You do them differently. They're easier. You just find the LCD and just top. Don't even worry about the bottom. Don't even look at your neighbors. Just top. Cancel. Multiply what's left over. Let's try another one. Okay, so there it is. So let me do the steps for fractions with equals. So fractions with equals, step 1, find the LCD, multiply top. Multiply to the tops, cross cancel, and multiply leftovers. Is everybody with me to there? So we take those fractions and we find the common denominator. Remember how to find common denominator? What's a common denominator? Do 3 and 5 have anything in common? If you put 3 and 5 in a box? In the L box? What goes into 3 and 5? Nothing, huh? So just multiply them together, huh? You can just do 1 if you want, yeah. 3 times 5 is 15. Is that good? If they have nothing in common, just multiply them together. So 15, but careful, am I racing ahead? You guys got these copied down? Is 15 the only 15 and don't forget x. X is also a denominator, right? So the common denominator is 15x. So right, so the LCD. 15 is the number part, but don't forget the x. So 15x. The LCD is 15x. So what am I going to do with that 15x? Multiply the tops. So I found the LCD, 15x, and now multiply 15x in the top, 15x in the top, 15x in the top. Goes top, top, top. Not the bottom. Notice I'm not going in here. All right, let's try this one. So 2/5, 8/27. What is that? Q over 45. All right, you got to do a big L box. I have no idea what that common denominator is. 5/27, 45. Who knows? Yeah, do 3, do 5, right? Do 9. Start breaking that down. I do not know. Makes 135. 135, right? 135. See if you get 135 should be your LCD. Do the L box? So yeah, so you put all 3 denominators in the L box, and you say, okay, what goes in? Like, you could do 5, for example. 5 goes into 5 once, 5 goes into 45 9 times. 5 doesn't go into 27, so we bring down the 27. Yeah, anything it doesn't go into, you just bring it down. Okay, now can we do another L box? What goes into 2 of those numbers? 3 or 9. Either one. I'll do 3 if you want. Just take you 2 steps. 3 goes into 27, 9 times 3 goes into 9, 3 times. 3 doesn't go into 1, bring it down. Then what goes into 2 of those numbers? 3 again. 3 goes into 9, 3 times 3 goes into 3 once. Bring down the 1. What goes into 2 of those numbers? Just 1. We don't do 1. 1 goes into everything. We're done. Where's our answer? Multiply, multiply, multiply. All these together, you get 135. Make sense? You guys okay with the L box thing? Remember how that works? You just keep dividing out what you can. All right, so 135 is the LCD. What do we do now with that LCD? Top, 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 right? I'm going to move it over, get some more room here. Are we good? So 135, so what am I going to do? I'm going to put 135 here. 135 here. And 135 there. You see that? 135, 135, 135. And now, divide on your calculator. Use your calculator to divide. But remember to cross off the numbers you divide, right? And write down the answer. Yeah, just take 135 divided by 5 on your calculator. Yeah, so cross, and then on the thing, cross off the things you just divided. What did I just divide? 135 divided by 5. I just divided those in my calculator. Cross those off and write down the answer. What's the answer? 27. And multiply the leftovers. What's not crossed off? What's left over? 27 times 2, 54. Does that make sense? So what you divide, you cross off. And the answer, you write down. It'll be left over. Multiply times the other. Did you right? Is getting it? 94 thirds or something? Is that what it is? Yeah. 94 thirds? Yeah. Right? So what happens in the middle here? You divide your calculator, 135 divided by 27, what is that? 5, yeah. 5, and the leftover, 5 and 8, multiply 40. Is that good? Everybody see what happened there? So cross off things you divide, write down the answer. 135 divided by 45, you calculate 3, right? Multiply the 3 in Q. That good? Now there's no more fractions. That's what's so great about this method. It gets rid of the fractions. So then what do we got? 94 is 3Q. Divided by the 3. We're done. Good? This will be easier than the last two sections once you get the hang of it. It'll be a lot quicker. You'll have no more fractions after one step. Questions on that one? Okay, so 1/5, minus 1/10 is 1 over x. Okay, same kind of thing. Got to find the LCD. Got to find the LCD. So put the numbers in a box. Unless you just know the LCD. So put the 5 and the 10 in a box. What goes into 5 and 10? Not what do they multiply to be? What little number goes into those two? 5 does, right? That good? Don't forget about the x. We'll put the x. The x is part of the denominator, so it's going to be part of the common denominator in a moment, right? So 5 goes into 5 once, 5 goes into 10 twice, like that. We good to there? Good so far. So what's the common? 5 times 1 times 2? 10. And you could have maybe just known that. 5 and 10 go into 10. 10. Now, don't forget the x, though. So the LCD is actually 10x. It's not just the 10. It includes the x. It's 10x. All right. So what am I going to do with it? Top, 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 huh? 10x, 10x, 10x. Top, top, top. So 10x, 10x, 10x. Is making sense? Take it from there. Cross cancel. Good. All right. 5 goes into 10. 2 times. What's left over? What's not crossed off? 2 and x and 1. You with me? That's just 2x minus. Right? Now in the middle, the 10s cancel. What's left over?
1.
X times 1, 1x. Good? Making sense? And then at the back, what cancels? X's. What's left over? 1 times 10? 10. Is that good? Let's just,
Put the one there?
X is 10. What's that?
Do we have to put the one?
No, yeah, good question. Yeah, you don't need the 1.
Okay.
1x is just x. Yeah.
It's confusing me if I put the one.
Not needed. So we're done. X is 10. We good? Does that make sense? That's the answer, because x is alone. Once x is alone, you're done. Yeah. That good? All right, so x plus 4 over x equals minus 5. So let me give you a second. First thing is to find the LCD and put it top, top, top. Give you just a second on that. Find the LCD and put it top, top, top. All right, what's the LCD? Yeah, the only thing in the denominator. Isn't that the only thing under any bar? So that's the only denominator. So that is the common denominator. If you're the only one, then you're it. Right? Does that make sense? There's nothing, if there was something else like a 3 or a 2 or something under some other bar, we would include those as well. But there's only one denominator. It's just the x. All right, so the LCD is x. What do I do with it? Top, top, top. Isn't that what we always do with the LCD on these equals problems? Right? So you multiply the LCD to the top, to the tops. Step 1. Step 2, cross cancel and multiply leftovers. All right, so when I cross cancel, I'm canceling numerators with denominators, huh? So these x's will cancel, but these guys will multiply. And this guy will multiply. Let me slow down. Did you catch that? Let me make that negative 5x. Why did the one in the middle cancel, but the other two, left and the right, multiply? Because only the one in the middle is underneath. Right? You only cross cancel with things under. Right? Top to bottom. Cross. Diagonal cancel. The one on the left and the right, they're just going to multiply because they're not underneath the bar. Does that make sense? We're only canceling out stuff under the bar. Right? It's dividing really. Right? To divide, you're going to have something in the bottom. You with me? Right? Okay, so now what? We got x squared. How do you, let me erase this. How do you solve x squared? Have you ever done that before? The answer is yes. Mr. Heron, we did that about 2 weeks ago. On the last exam, I remember it perfectly. Maybe that's the dream teacher answer. It's in my dreams. That it is true. We did do it 2 weeks ago. It was on the last test. What do you do for x squared? When you see x squared, remember I did the sea monster? Roar! X squared rears its ugly head. That help? No? You're thinking, what are you doing with the sea monster, you weirdo? What are you talking about? No, nobody remembers that? I worked these analogies for your good. No? You got to get a 0. Remember that? When the sea monster shows up, this is exactly how it happens. Like out of nowhere, you're doing something totally different, and x squared's like, here I am, I'm x squared. You got to get a 0. You got to factor at the parentheses. Remember that? Kinda, sorta, no? Is it coming back? All right, so yeah, as soon as you see x squared rear its ugly head, you've got to get a 0. What does that mean, get a 0? Grab this and jump it over here. When that negative 5x goes to the other side, what does it become? Positive 5x, right? When things jump to the other side, they change signs, don't they? And that puts a 0 on the right side. And I put it in the middle because I want the x squared x, no x order that I can now factor, right? X is in the front. What multiplies to be 4, adds to be 5?
4 and 1.
1 and 4, huh? Both positive. Adds to be 5 in the middle, multiplies to be 4. This coming back now? Remember this? And now what do we do from here?
You just flip the signs.
Yeah, you just flip the signs basically, right? Remember, so the answers are going to be -1 and -4. Because if you want to be formal about it, each one gets its own 0, is what it is. Because if two things are multiplying to be 0, either one could be 0 to make that true. Remember all that? And then you just jump it over, it's -1, -4. We're done. There's two answers to this question. You enter both answers separated by a comma, just like I have here, -1, -4. So we're combining what we did earlier with what we're doing now. Because x squared showed up on the scene all of a sudden. That's the answer. Two answers, -1, -4. So when x squared suddenly shows up, get a 0, factor. All right. Okay, so we have u over 5 minus 5 over u equals 0. What's first step on all fraction equals problems? Just a fractions with an equal sign. What's the first step?
LCD.
LCD. We're not making the denominators the same, we'll wipe them. Right? We'll take it on that. It's just 5u, right? Common denominator is just 5u. So what do you do with the common denominator, which is 5u? What do you do with it? Top, top, top. Right? We identify the LCD and we put it top, top, top. Remember, it's like a hitman. It's taking out denominators, right? I told you that whole hitman story, right? About the guy that visited my office a couple years ago, and he was a marksman for the army. So, take them out. Take them out. Take out the denominators. So 5 cancels 5. What's left over?
U squared.
U times u squared. Good. Take them out in the middle.
Minus 25.
U's are gone. What's left over?
Minus 25.
5 times 5, 25. Good so far. So cross cancel, multiply what's left over. What happens here? Is there any denominator to cancel anything? No, there's no denominator. It just simply multiplies. 0 times 5u, 0 times anything? 0. Okay, the sea monster has reared its ugly head. There it is, u squared. What are we going to do?
Two parentheses.
Yeah, get a 0. We've already got the 0, so factor with the parentheses, yeah. Right?
Positive 5 and negative 5.
Yeah. Plus 5 minus 5. So the answers are negative 5 and positive 5. Either order doesn't matter. We good? So what are we doing on these? LCD, top, top, top. Everybody getting the hang of that? LCD, top, top, top. And then cancel, multiply what's left over. That's how you do the equal sign problems, which is this whole section. Okay, so 3 over 7y plus 3 over y is 1. All right, what's the LCD on that one? Find the, look at the, remember for LCDs we take one, remember shopping? We take one, we're going to Target, we're buying one of every variety. Remember LCD? It's one of every type. So look at the denominators and take one of everything. That'll be the LCD and then put it top, top, top. No. So we're not doing what we did in the last section. Oh, you're right. You're right. Yeah. Good. Great that bar. Here. Well, just 'cause it looks like you have one big bar instead of 2 separate bars. Yeah, LCD 7y, huh? Just 7y? Does that make sense? LCD is just 7y. And then so you put 7y top, top, top. Is that making sense? How are we doing? That good? Does it make sense? 7y, 7y, 7y. And then we cancel. 7y, 7y, gone. What's left? 3. Good for that first fraction? So on the middle fraction, what can you cancel? Y with y, what's left over? 3 times 7, 21. Right? You multiply whatever's left over. We good? And last, are these just multiply 1 times 7y is just 7y. Is that good? Getting the hang of that? No more fractions after the first step, right? And then what's that? 24 is 7y. Last step?
4.
There it is. 24 sevenths? Questions on that one? Are we good? So x minus 8 over x minus 9 is 1 over x minus 9. All right, what are we going to do first on that one? Yeah, just cross it. It's just diagonal, diagonal, huh? It's just one fraction on each side. Just cross multiply. Diagonal, diagonal. Diagonal, diagonal. Does that make sense? It's just one fraction on each side. We good? Making sense? And then distribute. X squared minus 9x minus 8x plus 72. X minus 9. You good to there? Everybody good to there? So x squared. There it is. The sea monster's reared its ugly head. What do we do? When you see x squared with an equal sign, what do? Step number 1, you get a 0 to the rescue, right? You got to get a 0. Whenever you see x squared with an equal sign, you got to get a 0. You good to there? Am I going too fast? Everybody see what I did? Everybody good to there? Right? Everybody see what happened? I got a 0. Let's bring that up here and factor it. How do you factor that thing?
9 and 9.
minus 9, right? Multiplies to be positive 81, adds to be minus 18. Good. And so you know the answer is just going to be plus 9, right? Because it's always opposite sign. Is that okay? I just jump there? Because maybe I shouldn't jump. So you said each one equal to 0, right? Because if two things are timesing to be 0, right? These are timesing to be 0. Either one could be 0 to make them multiply to be 0. So then jump it over. It's positive 9. The answer is positive 9, but it's actually no solution. After all that work. Yeah. This is a weird one. I'm not going to put this on the test. I wanted to show it to you. It's because it makes the denominator 0. If you go back in the beginning, see how if you put the 9 in back in the beginning to that denominator x, 9 minus 9 is 0 on the bottom. You can never make the bottom of a fraction 0. You know 0 underneath is undefined if you divide by 0. Don't got time to talk more about it. Not going to put it on the test. If you're interested, come see me offstairs. I'll talk your ear off all about the world of undefined and false solutions and what that all means. I imagine most of you aren't interested. That's fine. It's no solution. So I'll move on. It won't be. Okay. Let's try this one. So 4 over x minus 3 plus 5 over x plus 3 is 4x over x squared minus 9. First thing that needs to happen, what do you got to do with that x squared minus 9? You got to factor that, huh? Let's do that right now. How do you factor x squared minus 9?
3 and 3.
Plus 3 minus 3, right? Let's just do that right away. Everybody good with that? Okay, can we stop a second? And I want to make a point real clear. Your homework's going to be very frustrating for you if you don't get this point. This problem is super similar to the ones we had at the beginning, first hour, where we would look at the neighbors and give them what are missing. But I'm not going to do that on this problem because this one has an equal sign. So you have to see that difference, or not only are you going to be messed up in this weekend's homework, but on the next exam. Because it's so similar looking, right? In fact, the only thing that's different is the equal sign. If that was simply a plus sign, then it would be one of the problems from the last section, or yesterday's homework, where we do the neighbors and give them what's missing top and bottom, right? So you really have to get this concept, and it's subtle. It's not going to come to those that are sitting right now in a fog. You've got to hone in and hear what I'm saying and look carefully and think precise, cutting thoughts that distinguish one thing from another that are slightly different, but the difference matters a lot. Equal sign, no equal sign. That's the difference. And that's a huge difference. Even though it's a tiny little symbol, it makes all the difference in the world. I just removed the equal sign. It really has an equal sign. But I wanted to show you the other kind. If there was no equal sign, that's what we did in the first hour, right? That's not solving an equation if there's no equal sign. There's no left side, there's no right side, right? If there's no equal sign, there's no left and right, right? You with me? That's the main thought you want to have in your head. You want to start thinking. The problem a lot of people get into in math is it just is all kind of like fuzzy symbols all over the place. I mean, I know that begins to happen, but that means you need more time. More time working, thinking, meet with your teacher. I used to hang out with my teachers all the time. You got to get help. You got to put time in it. Math doesn't come to the casual. It does not come. It's like learning Chinese. You can't learn Chinese 10 minutes a day relaxing in front of the TV. It's not going to happen. Right? Chinese is too hard. Math is too hard. So, catch these thoughts. Equal sign, big difference from no equal sign. Huge difference. All the difference in the world. What is that difference? With an equal sign, you have a left and a right. You have two sides. All of my thinking with an equal sign is, hey, I got a left side and a right. Put the wall in. I think that'll help. I'll just maybe jump off the page a little bit more to you. Left side, right side. All of my thinking is, hey, the left side equals the right side. So whatever I do to the left side, I'm going to do to the right side. Am I thinking top and bottom? Not at all. I'm not thinking, hey, whatever I do to the top, I'm going to make sure I do to the bottom. Not with an equal sign. All of my thinking when there's an equal sign is left and right. That's why I do not do the following thing. I'm not going to go, oh, you know what he needs? His neighbors have an X. Don't write this down. This is wrong. But I want to show you why it's wrong. This is the mistake I see tons of. People go, oh, and this one, he needs an X plus 3. Right? Now they're all the same. That's what you said. Make them all the same. Yeah, that's great. If this was a plus instead of an equals. That's what we did in the first hour. That's perfect for the first hour when there was no equals. Why is it so wrong now? Because I shouldn't be doing top and bottom. I shouldn't be putting things top and bottom. I shouldn't be thinking about top and bottom at all. Why not? Because I have an equal sign, which means there's a wall, which means it's all about the left and the right, the left and the right. It's an equation. Whatever you do to the left side, you do to the right side. I'm thinking left, right. When there's no equal sign, then you're doing top, bottom. Are you catching that big idea?
Yes.
So in math, we're always working with a balance. But there's two ways to do that balance. There's top and bottom, and there's left and right. That music made my talks dramatic, kind of fun, right? Left and right or top and bottom. That's what I thought personally. Anyway, left and right or top and bottom. So you always want to think, okay, which way am I doing the balance here? Top, bottom, or left, right? How do you know? If there's an equal sign, it's left, right. Meaning, don't think top, bottom. Whatever you do on the left, do on the right. If there's no equal sign, then there's no left, right, so it's top, bottom. Are you getting that? That's the difference between the first hour and this hour. So when I look at this problem, I know I'm not going to do top, bottom, top, bottom. Why? Because I have an equal sign. So I think, oh, I'm not doing top, bottom. I'm doing left, right. Top only. So equal sign, left, right, top only. That's a funny looking name. Top only, top. So that's why I'm still doing the LCD. I mean, so much of it is still the same. That's why the difference is subtle and it fools so many people because it is a small difference. It is. I see why it's confusing. And that's why I'm trying to make a big deal to make it clear for you because it is confusing. All right, so having said all that, let's do the right thing now. So what is the right thing? Well, the right thing is to find the LCD and put it top only. What is the LCD? In fact, I'll say the whole LCD. Top one. Not just the missing part. That's where people get messed up. Oh, I'm supposed to give it what is missing. No, that was the other method. That was the other method, top, bottom, give them what they're missing. This one, I'm going to do the whole LCD. What's the whole LCD? Well, you know what the LCD is, right? You take one of each. Shopping. So it's x minus 3, x plus 3. Whole thing in the left. X minus 3, x plus 3. Whole thing in the middle. X minus 3, x plus 3. Whole thing on the right. Whole thing. Top, top, top. That's the right thing. Write that down. That's right. That's the correct thing to do. Why? Because it's an equal sign. You got to make sure whatever you put in the top of the terms on the left, you put in the top of the terms on the right. You're doing the same thing to the left side as you are to the right. Yeah, but you're not doing the bottom, right? I don't care about the bottom. I'm not thinking about the bottom. I'm thinking left, right. Because I have an equal sign. It's called the principle of equality. If two things are equal, you treat them the same, they'll be equal afterwards. Right? We all know that's true. That's what's leading me, guiding me, is the fact that the left equals the right. So whatever I do to the left, I do to the right. I don't care about the bottom. Top only, left and right. Whereas, all I would have to change is that equal sign to a plus, and it would be a problem from the first hour. Subtle difference, right? You got to be looking for it. It's not going to reach off the page and grab you, slap you in the face, and say, this is the top bottom, this is the left right. No, you got to be looking for it. The symbol's small. This fourth exam will separate people a little bit. I don't mean to make it that way. This material is just harder. Grades usually drop. I'm not meaning to discourage you. You can still do great. Some people still fly high with high A's. But some who were doing well have a little more trouble. It's going to take more time. If you want to keep getting the same grades you got in the first three, you're going to need to study this one harder. Because of problems like this, they're more subtle and it gets easily confused. So cancel, right? What's left? 4x plus 3, cancel. What's left? 5x minus 3 equals. Cancel, cancel. What's left? 4x. See what happened there? I cross-canceled and multiplied what's left over. Everybody see that difference? When do you do the top-bottom, give them what they're missing, look at your neighbor's thing that we did in the first hour? No equal sign. No equal sign. It's all about equal sign or no equal sign, right? Because with an equal sign, you're doing left-right. You're not doing top-bottom. You're not looking at your neighbors. If there's no equal sign, you got to do the same thing top and bottom. Right? There's two ways to balance. All right. So then we distribute 4x plus 12, 5x minus 15, 4x. What's that? 4x and 5x is 9x. 12 minus 15 is minus 3. Bring it up here. This one's a mess. 9x minus 3 is 4. How do you solve for x there? Yeah, the easiest way would be to subtract that 9x, yeah. And then you would get, what would you get? Minus 3, whoops. Not x, huh? Just minus 3. Equals minus 5x. Divided by the minus 5. So that's 2 negatives. Positive 3/5. Whew. That was a lot of work. X is positive 3/5. Does that make sense? That's not easy, but you can do it with practice. You can do it, but it will take more practice than the last test material took. Are we good with that? Are you happy about that? Questions I can answer? I wish I had more time to be more helpful, but that's all the time we have. This will take practice. All right, the clickers are open. Click on A.